Okay, so picture this. You're having a picnic, enjoying the day, and suddenly here come the ants marching in formation right towards your food. We've all seen it. But I bet you never considered that those tiny ant brains are buzzing with more than just instinct. They're actually swimming in this complex cocktail of chemicals that shape their every move. And that's what we're diving into today, the fascinating world of ant neurochemistry. We've got a stack of incredible scientific articles right here, ready to reveal how brain chemicals like dopamine, serotonin, and octopamine are the secret puppet masters behind everything from an ant's role in the colony to how it interacts with its buddies or even its enemies. Get ready because some of these studies are truly mind blowing and might just change the way you look at those ants staging a hostile takeover of your picnic basket.
Yeah, it's easy to dismiss insects as just behaving purely on instinct. But ants, they're in a league of their own. They demonstrate this incredible behavioral flexibility, adapting to changes in their environment, making decisions about foraging, defending their colony, and even engaging in these complex social interactions. And increasingly, we're finding that biogenic amines, like you mentioned, hold the key to understanding this hidden world of ant complexity.
It's like what we see on the surface, those bustling ant colonies, are just the tip of the iceberg.
Uh,
Underneath, it's this whole intricate world of brain chemistry calling the shots. So let's break down these biogenic amines. What are they exactly?
So imagine them as the maestros of the ant brain. These molecules act as neuromodulators. They fine-tune how neurons talk to each other. Think of it like a network of walkie-talkies. The biogenic amines control the signal strength, ensuring clear communication. And this communication ultimately shapes an ant's behavior, influencing how it responds to everything from changes in its environment to interactions with other ants.
Okay, so if the ant brain is like a bustling city, these biogenic amines are the traffic signals directing the flow of information.
Exactly. And in the research you've provided, we see three key players in this system: dopamine, serotonin, and octopamine. Each one has its own unique role to play in the ant brain's fascinating drama.
Yes. And some of these studies are wild, like that one from 2008 where researchers basically gave queenless fire ants an octopamine boost. Suddenly they're able to recognize intruders again. Talk about a brain upgrade.
Ah, yes, the work by Vandermeer and his team. They discovered that when a queen was removed from a colony, both the worker ants' brain octopamine levels and their ability to distinguish nestmates from strangers dropped.
It's like they lost their social compass without their queen. But then researchers fed those same ants octopamine and boom, their recognition abilities bounced right back.
It suggests that the queen plays a crucial role beyond just reproduction. She might actually help regulate worker behavior by influencing their brain octopamine levels.
That's incredible. But then there's that other study, the one on carpenter ants, where octopamine seemed to make them less generous with their food.
Right. The 2005 study by Shiska and colleagues, they were looking at how octopamine affected trophallaxis. That's the fancy term for how ants share food with each other.
Yeah.
It's a big deal in ant colonies, right? Sharing resources is key to their survival.
Absolutely. But in this case, injecting the ants with octopamine made them less likely to share their food with their nestmates. Who knew ant social lives could be so cutthroat?
What's fascinating is that this study suggests octopamine doesn't have a simple on or off switch for social behavior. It seems to have different effects depending on the context. In the fire ant study, it promotes colony cohesion. But in the carpenter ant study, it encourages more individualistic behavior.
Wow. So it's not just octopamine equals more social or less social. It's about how this one chemical can fine-tune behavior in very specific situations to benefit the colony as a whole. That's way more sophisticated than I would guess.
Absolutely. And this just goes to show how much we're still learning about the complexity of these systems.
Okay, but now we have to talk about the parasitic butterfly larvae. This one sounds like it's straight out of a science fiction movie. These larvae basically drug ants with dopamine-laced honeydew, turning them into their personal bodyguards.
That's the 2015 study by Hojo and colleagues. A perfect example of how understanding ant neurochemistry can reveal some truly bizarre ecological interactions. They were studying the relationship between the lichenid butterfly and the ants that tend to its larvae.
And what they found is that these butterfly larvae produce a sugary honeydew that ants can't resist. But here's the catch. It's spiked with dopamine.
And we're not just talking about a little sprinkle of dopamine. This honeydew is like a dopamine espresso for ants. It not only makes them crave the honeydew, but also changes their behavior.
The ants become less active, almost sluggish, and way more aggressive towards anything that threatens those larvae. They become the butterfly larvae's personal army, totally under their control. It's like something out of a horror movie.
A perfect example of manipulation in the natural world. And it gives those butterfly larvae a huge advantage, ensuring they're protected from predators and parasites. It makes you wonder what other mind control tactics are out there in nature just waiting to be discovered.
It really makes you see those seemingly innocent ants crawling around in a whole new light, right? Okay, so we've seen how octopamine can be like a social regulator, fine-tuning interactions between ants. But what about ambition? That drive to climb the social ladder? That's where dopamine comes in, right?
You got it. Dopamine is often linked to reward and motivation.
Mhm.
And in ants, it seems to be closely tied to aggression and social dominance.
So the more dopamine an ant has coursing through its system, the more likely it is to throw down for a higher spot in the colony hierarchy.
It's a bit more nuanced than that, but
Right.
you're on the right track. A 2014 study on Diacoma ants, the ones where the workers actually duke it out to become queen, found a strong link between dopamine levels and who
Right.
came out on top.
Oh yeah, Diacoma ants. Those girls don't mess around. It's like Game of Thrones in miniature.
Exactly. And what's really interesting is that researchers observed this surge of dopamine in the worker ants right when these dominance tournaments began. It's like a chemical shot of ambition saying, go get 'em, tiger.
Wow. So it's not just about acting tough, it's about who's chemically primed for the crown.
And here's where it gets even more interesting. The study found that dopamine didn't just correlate with aggressive behavior. It seemed to directly influence the ants' reproductive systems. Applying dopamine to subordinate workers actually triggered oocyte egg growth, essentially preparing them physically for reproduction.
Whoa, talk about a power move. But hold on a second. If dopamine is all about climbing the social ladder, what keeps it in check, you'd have total anarchy in the colony if every ant was hopped up on dopamine, right?
You've hit on a crucial point, and this is where social regulation comes into play. Remember that study on dichoma ants we mentioned earlier where contact with the queen or even just interacting with dominant workers seemed to lower dopamine levels in the subordinate ants?
Right. It's like a chemical reality check. The ant brain gets a taste of dopamine, thinks, I could rule this colony, but then those social cues come in, and it's like, nope, not today.
Precisely. It highlights how important that delicate balance of dopamine is for a colony to function smoothly. Too much, and you have constant conflict and competition. Too little, and the ants might lack the motivation to carry out their essential tasks. It's all about finding that sweet spot between ambition and order.
Fascinating. It's like this intricate dance between brain chemistry and social dynamics. Okay, so we've covered dopamine, the ambition molecule. What about serotonin? It often gets labeled as the happy chemical in humans, but what about in ants? Is it all about good vibes in the colony?
Well, serotonin's role in the ant brain is a bit more complex than just happiness. While research is still ongoing, studies suggest it plays a key role in things like foraging behavior and how ants respond to stress in their environment.
Okay, so maybe less about good vibes and more about getting things done and rolling with the punches.
You could say that. One study on Phytodentata ants, you might know them as big-headed ants, found that older, more experienced foragers had higher levels of serotonin in their brains compared to their younger, less experienced counterparts.
Interesting. So maybe serotonin is like a seasoned scoutmaster, helping them stay focused and on task during those longer, more complex foraging missions.
It's a compelling theory, and what's even more intriguing is that the same study found that giving the ants a serotonin precursor, something that helps their bodies produce more serotonin, made them more likely to leave the nest and follow those pheromone trails to find food.
Wow, so it's like they gave those ants a serotonin boost and they were raring to go on a foraging adventure. That's incredible. But we've mainly focused on how these brain chemicals influence individual ants. What about the bigger picture? How does all of this tie into the success of the entire colony?
Ah, yes, the million-dollar question.
And sadly, I don't have $1 million for you. But hey, maybe one day this podcast will win a Grammy and then...
A Grammy would be fantastic. But you're absolutely right, the true value here is understanding. And while we're still in the early stages of unraveling the complexities of ant neurochemistry, it's clear that these biogenic ains are essential for orchestrating the behavior of thousands of individual ants into this cohesive functioning superorganism.
A superorganism that can survive for years, even decades, right? Outliving the individual ants themselves.
Exactly. And that incredible longevity is a testament to the power of their social organization, all made possible by these tiny chemical messengers in their brains.
It's mind-blowing, isn't it? To think that these tiny creatures we often overlook hold such profound secrets about social behavior and maybe even about ourselves. It really makes you wonder, what else can we learn from these little guys? Is there something about ant brains that could help us understand, say, human behavior? Are we really that different from an ant colony when you get right down to it?
It's a fascinating thought, isn't it? We humans might be more complex than ants on an individual level, but when you look at the bigger picture, we both form societies rely on communication and cooperation, and even struggle with things like conflict and social hierarchies. And many of the neurochemicals that govern ant behavior are found in our own brains too.
So by studying how these chemicals shape ant societies, we could potentially unlock new insights into the evolution of social behavior more broadly, even in humans. Now that's what I call a deep dive.
Precisely. And it gets even more intriguing when we consider the practical applications of this research.
Oh, like what? Give me the good stuff.
For one, a deeper understanding of ant neurochemistry could revolutionize pest control. Imagine being able to disrupt the social organization of invasive ant species, the ones that get into everything, by simply tweaking their brain chemistry.
So instead of those harsh chemical pesticides, we could potentially develop more environmentally friendly solutions that target the ant's behavior directly. Now that's what I'm talking about.
Exactly. And it doesn't stop there. Research into the neurochemicals that regulate ant behavior might even hold clues for developing new treatments for human neurological disorders. Remember those dopamine derivatives found in ants that I mentioned earlier? They've shown some promise in treating Parkinson's disease and even stimulating neural stem cell growth.
Right. It's amazing to think that these tiny ant brains could be the key to major medical breakthroughs for humans.
Hmm.
Okay, so to recap what we've learned today, ant behavior isn't just about blindly following instinct. There's this whole symphony of brain chemicals, dopamine, serotonin, octopamine calling the shots behind the scenes.
A perfect analogy. And by continuing to explore these intricate worlds within ant brains, we stand to gain incredible insights, not just into these fascinating creatures, but also into the very nature of social behavior, the evolution of complexity, and maybe even our own place in the grand scheme of things.
It's enough to make you want to go find the nearest anthill and just stare in awe.
I'd say that's a worthy pursuit.
So the next time you see an ant colony, remember, there's a whole lot more going on beneath the surface than meets the eye. It's a complex chemical ballet that has been fine-tuned over millions of years of evolution, and we're only just beginning to appreciate its elegance. And for our listeners, what surprised you the most about today's deep dive into the world of ant neurochemistry? Head over to social media and let us know using the hashtag #AntBrainBlown. We might even feature your comments on a future episode. For the deep dive, I'm your host, Name.
And I'm Expert Name.
Thanks for listening.